You know that feeling when you step out into the sun and it just feels amazing? We usually just write it off as a simple mood boost, right? But what if I told you there's a connection between sunlight and our bodies that's way deeper, way more essential than we've ever thought? Well, we're going to get into it. And look, the answer isn't just, oh, it's vitamin D or it feels warm. No, no. We're talking about something that connects astrophysics, quantum biology, and a secret that's been hiding in plain sight, in the very light that hits our planet every single day. Okay, so to really understand this connection, we've got to start with something you've probably heard of before, but we're going to look at it in a whole new way. I'm talking about the Goldilocks zone. Yeah, we all learned about this one in science class, right? The Earth is just right, the perfect distance from the sun for liquid water, which is, the foundation for life. But what if that's just scratching the surface? What if there's a much more intimate, a much more fine-tuned relationship between our sun and our actual cells? Okay, this is where it starts to get really, really interesting. This deeper relationship, it all starts with how we've been looking at sunlight. And it turns out we might have been looking at it the wrong way. There's a catch. If you go online and look for a graph of the sun's energy, this is what you'll find 9 times out of 10. It plots the sun's energy against wavelength, and it seems pretty clear, right? The peak is right there in the visible spectrum. The colors we can see. This is what plants use for photosynthesis. It makes sense. But what if that's not the whole story? What if it's not even the most important part of the story for us? And this is where an astronomer named Bob Fosbury comes in and completely flips the script. He says, look, for biochemistry, for what's happening inside our cells, what really matters isn't the total energy. It's the number of little energy packets, the photons, that are hitting us. So what happens when you replot the graph, not by total energy, but by the number of photons? Well, the picture changes completely. The peak isn't in the visible range anymore. It's not even close. Instead, this absolutely massive, Everest-like peak just pops up in the near-infrared range. That's a type of light we can't even see. And the very top of that mountain, the absolute peak where the sun is pumping out the most photons, it's right around 0.75 electron volts. Now, I want you to remember that number. Seriously, it is the key that unlocks this entire mystery. So, okay, the sun is just blasting us with a crazy number of photons at this one specific energy level. So what? Why does that matter? Well, because it just so happens that our own biology seems to be perfectly, and I mean perfectly, tuned to catch them. See, our bodies have this thing called a tissue transparency window. Think of it like this. UV light kind of bounces off our skin, right? But light in the deep red and near-infrared spectrum, it can pass right through, going deep into our tissues, reaching our muscles, our organs, everything. And here's where it all clicks together with 2 absolutely incredible coincidences. Are you ready for this? First, that 0.75 electron volt peak from the sun, the most common photon it sends us, it lands smack dab in the middle of our body's transparency window. It's like life carved out a window specifically to let in the sun's most abundant light. And second, the amount of energy the sun pours through that window is almost a perfect 1-to-1 match for the energy our own bodies are giving off. It's this beautiful, perfect energy balance. So our bodies are just soaking up all of this invisible near-infrared light. The big question is, what are we doing with it? The answer is really subtle. It's all about making the little engines inside our cells run a whole lot smoother. Now, this is super important. This isn't like plants where light is the food. For us, the fuel is the food we eat, the carbs, the fats. Think of this near-infrared light as the high-performance oil for your car's engine. It doesn't replace the gasoline, but it makes the engine burn that gasoline way, way more efficiently. And here's how it actually works. Inside our cells, we have these little power plants called mitochondria. When it's dark, they have to use this really slow, difficult process called quantum tunneling to make energy. It's like trying to walk through a wall. But when that near-infrared light is present, the electrons get this little energy boost. Instead of tunneling through the wall, they can just hop right over it. It's faster, it's easier, it's just a better way to do business. What gives them that boost is something called a phonon bath. It sounds complicated, but it's not. Those incoming photons make the water inside our cells vibrate. They literally create this warm, vibrating energy bath. And that's what gives the electrons the little kick they need to make that hop. It is, quite literally, the oil for the machinery of life. And again, this is not just some random happy accident. It looks like our bodies, right down to the tiniest nanoscale level, are actually incredibly sophisticated machines that are designed to capture and use this light.
You could say that we are, in a very real way, walking, talking, biological solar panels. We've evolved these complex structures not just to let this light in, but to actively grab it, hold on to it, and manage it.
You know how plants have these tiny structures to trap the exact colors of light they need for photosynthesis? Well, it turns out we have something similar in our cells. Things like the endoplasmic reticulum are layered in just the right way. They're perfectly scaled to trap near-infrared light. They basically create a photon traffic jam, making the light bounce around and stick around for longer inside our tissues. This gives our cells a much better chance to absorb and use that energy. Okay, so if our biology is this deeply connected to the full spectrum of sunlight, what does that mean for us today, living our modern, mostly indoor lives? Well, it forces us to rethink some pretty big ideas we have about health. All right, let's take a really popular one. Blocking blue light at night. Everyone's doing it, right? The thinking makes sense. Cut out the stimulating blue light so you can sleep better. But with everything we've just learned, what if we're all focusing on the wrong part of the problem?
And this really gets to the core of it. The issue with our modern lights isn't that blue light is bad. There's nothing inherently wrong with blue light. The real problem is the absence of everything else. It's blue light all by itself, without the calming, healing, red and near-infrared light that has always come with it out in the natural world.
For millions of years, our bodies evolved expecting that full, rich solar spectrum. But now, we spend all our time indoors behind windows that block near-infrared light and under LED bulbs that give off a ton of blue, but almost zero infrared. We've basically put ourselves on a light diet that's missing a key nutrient. You could say we're infrared deficient. And so that leaves us with a really big, critical question. If full-spectrum sunlight with that huge peak of near-infrared photons is basically a high-quality nutrient that oils our metabolism at a quantum level, what happens when we take it out of our diet? What are the consequences of removing this fundamental part of our environment? Thinking about that? Well, it might just change the way you look at light forever.